Okay, in this video, I'm going to show you how to graph functions using derivatives. Okay, so we'll start with this simple function f of x is equal to x over x minus 1. Now, before you use the derivatives in helping you to graph the function more accurately, you need to find or you need to determine three important values of the function. The first one is the domain of the function. So the domain of the function is the set of numbers that are allowed for the values of x. So if the function is a rational function, we know that there are some restrictions in the denominator. And the restriction will come from the idea that the fraction cannot have a zero denominator. So x minus 1 cannot be equal to 0. And this will happen only if x is equal to 1. Hence, x cannot be equal to 1. So the domain of the function, so we write the domain is any x as long as it's part of the set of real numbers, so it's an element of the set of real numbers, but there is a restriction, and that is x cannot be equal to 1. So this is the domain. So when you graph the function later, you will see that you will not get any value of y for that particular value of x, which is x equals 1. Okay, the next thing that you need to find in graphing a function is or are the x and y-intercepts. X-intercepts are the values of x in which the graph will cross the x-axis. On the other hand, the y-intercept will be that part of the graph. This is the y-intercept. These are the x-intercepts. So y-intercept or intercepts are the points in which the graph will cross or touch the y-axis. Okay, so how do we find the x and y-intercepts of the function? The idea is all the x-intercepts will have y value equal to 0. Any point on the x-axis will have y equal to 0. So that means if I want to find the x-intercepts, then I have to set the function, which is the y, so this is the y. I have to set this function to 0. So that means 0, so f of x is 0, and then x over x minus 1. So I have to find an x that will make this equation true. So by simply solving this equation, we can multiply both sides by x minus 1, as long as x is not equal to 1, of course. So the left side will be 0, and the right side will become x. And as you can see, the x-intercept is x equal to 0. Meaning, if this is the x and y axis, the graph will be crossing or touching the x-axis at x equals to 0. Now, how do we find the y-intercept? It's a similar idea. Every point in the y-axis will have x or 0 as x. Okay? So, if this is the function, so if f of x is equal to x over x minus 1, to find the y-intercept, all I have to do is to replace x by 0. So this will become 0 over 0 minus 1, which is equal to 0 over negative 1 equal to 0. So the y-intercept will be at y equal to 0. As you can see, we already obtained x is equal to 0 when we look for the x-intercept. And since we have the same condition for the y-intercept, we ended up with the same numbers. Okay, but this is just a coincidence. It's just a coincidence that x is equal to 0 and y equal to 0. This can be different numbers. This can be a 1 and this can be 2 depending on the function. Okay, but the main idea, if you want to find the x-intercept, you have to set your y equal to 0 because all the x-intercept will have 0 as the y. If I want to find the y-intercept, then the main idea is that all x, or all points rather, on the y-axis will have x equal to 0. And that is why we replace the x by 0. Okay, so our conclusion, our answer for this question is that the x-intercept is x equal to 0 and the y-intercept is y equal to 0. Okay, now we're down to the third. So we want to find the vertical and the horizontal asymptotes. It's the VA and the HA. So VA, so vertical, so the line should be or should have an orientation this way. Horizontal will be in this way. Okay, all vertical asymptotes will have the form x equal to a number, and all the horizontal asymptotes will have the form y is equal to a number. Okay, so how do we find these asymptotes? Let's start with the vertical asymptote. The vertical asymptote is that part of the graph. So say if this is x and y axis, so the vertical asymptote, so normally in the graph you can see the vertical asymptotes as dotted lines. So in the graph, these lines are the lines in which the graph tends to move closer and closer, but it will never cross that line. So some graphs can have this orientation, some graphs can do the other way, it can do the other way, or on the right side it can have this orientation or in the other direction. But the idea is the graph will not pass through that line. It's either it will move closer and closer and then you indicate it by an arrow, then it will be jumping on the other side, and then that part of the graph will also move closer and closer to the vertical line, and then but it will not cross the vertical line. Okay, so that's the vertical asymptote. Now the horizontal asymptote is the same idea. So if I have the x and y axis, the horizontal asymptote, so from the term horizontal, so it will be a horizontal line. So you will also, or the graph will also move closer and closer to that line. Okay, but unlike the vertical asymptote, it is possible for the graph to cross a horizontal asymptote. Sometimes it's just on one side that you can see the graph approaching the line, and on the other side it's crossing the graph. I mean the asymptote. So that's perfectly fine for horizontal asymptote. But for the vertical asymptotes, you will never have a chance that the graph will pass through that line. Okay, so knowing this idea, so how do we find the vertical and the horizontal asymptotes? So let's start with the vertical asymptote. By its nature, you will not get any value on that x. So basically this r, or this is the x, or are the x's that are part of the restriction of the domain. So if we go back to the domain, if you recall, in the domain x cannot be equal to 1 because if x is equal to 1, the function will become undefined. So that's actually that will give us the vertical asymptote. The vertical asymptote in this function is at x. It is named as x equals to 1. It's the line passing through the value 1. So if this is 1, so it's passing through the value of x, which is equal to 1. And we write the vertical asymptote as x equal to 1. Now the next one is how do we find the horizontal asymptote? So for the horizontal asymptote, we base it from the form of the function. it's about the degrees of the numerator and the denominator. There are just three cases in which you can identify the horizontal asymptote. The first one is, say, I'll use some examples. So say the function follows this format. So you have an x squared plus blah 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 and plus blah blah blah, and then x cubed plus something something, and then plus and so on. So all you have to do is to compare the first terms if the numerator and the denominator are arranged from highest degree to the lowest degree. So suppose this is the highest degree of the numerator and x cubed is the highest degree in the denominator. So by just comparing, if the degree in the numerator is less than the degree of the denominator, then the horizontal asymptote will be y equal to 0. It will be the x-axis. The y equal to 0 is the x-axis. Okay, so that will be acting as a horizontal asymptote. Now the second case, what if the case is reversed? Let's make this bigger, and then in the denominator is just x squared. Then you have plus something and then plus something here. Now if this is the case, then you will never get a horizontal asymptote. So just simply say there's no horizontal asymptotes. And the third case, if say I have 3x and 4 and below is 2x to the 4, so let's just make a copy of the third case here. So we have 3x to the 4 over 2x to the 4, 3x to the 4 over 2x to the 4, and the degrees are the same. The horizontal asymptote will have the equation y equal to the leading coefficients of this expression. So you take the 3 and then you take the 2, that will be your horizontal asymptote. Meaning, so if let's say this is the horizontal asymptote and this is the value 3 over 2 at this point, then the horizontal line will pass through that y value, which is 3 over 2. Okay, so remember the three cases: lesser degree in the numerator than the denominator, then it will be the x-axis, which is y equal to 0. And then if the numerator has a higher degree than the denominator, then there is no horizontal asymptote. But if the degrees are the same, say x to the 4 over x to the 4, x to the 5 over x to the 5, then the horizontal asymptote will be y equal to the coefficients of the leading terms. Okay, so in this case, we have y equals to x over x minus 1. They have the same degree, so as you can see, this is x and x. So the horizontal asymptote will be the coefficient of x, which is 1, and the coefficient of the denominator, x is 1, so this is simply 1. So y equals 1 is the horizontal asymptote. Okay, so just a recap of the first three steps in graphing the function. So you need to know how to find the domain, and then the x and y-intercepts, and the vertical and the horizontal asymptotes. So this will be the first part of this video. So I'll be showing you how to use the derivatives in order for us to graph this function. Okay, so we'll stop here and then you need to view the next part of this video.